We're given a trig integral, sine squared x cosine squared 2x, which deals with two trig entities that both are squared. We have sine squared and cosine squared. Because they're both squared, I think it would be best for us to tackle this by using some trig double angle identities in order to step them down and make them easier to integrate. So first up, we'll rewrite this as the integral of, in parentheses, 1 minus cosine 2x over 2 times 1 plus cosine, and this is a double angle, so we will double the angle of 2x, and we'll rewrite that as 4x over 2 dx. And now we just multiply these two together. We get 2 times 2, which is 4, and we'll kick out front a 1/4. And then we can go ahead and FOIL the numerators. So we'll do that now. We'll start with 1/4 times the integral. 1 times 1 is 1. And here we have 1 times cosine 4x, and then minus 1 times cosine 2x. So we will add plus cosine 4x minus cosine 2x, and then we'll multiply cosine 2x times cosine 4x, and we'll have minus cosine 2x cosine 4x dx. And here we can use the trig property of product to sum. And so this can be rewritten as cosine A times cosine B, which can be equaled to 1/2 times cosine A plus B plus cosine A minus B. And so plugging our values in, cosine 2x and cosine 4x, what we get here is cosine 2x cosine 4x equals 1/2 times cosine 2x plus 4x plus cosine 2x minus 4x. Simplifying, we get 1/2 times cosine 6x plus cosine 2x. Now you might be wondering why this isn't cosine negative 2x, and that's because cosine is an even function, and so cosine of negative theta equals cosine theta. Therefore, we can go ahead and write this as 2x. And so now we can go back to our original function and rewrite it as 1/4 times the integral of 1 plus cosine 4x minus cosine 2x minus, and now we can plug in this here, 1/2 times cosine 6x plus cosine, go ahead and erase this, 2x dx. For simplicity's sake, I'm going to rewrite this once more, but I'm going to split these two integrals. So I have 1/4 times the integral of 1 plus cosine 4x minus cosine 2x minus, we've got 1/4 again, but we're going to multiply it by 1/2, so we'll say 1/8 times the integral of cosine 6x plus cosine 2x dx. I'll put that dx there as well. Now all that's left to do is to integrate these two integrals. So we'll start by integrating the left-hand side. We'll do 1/4 times the integral of 1 with respect to x is x. The integral of cosine 4x with respect to x is plus sine 4x over 4. The integral of negative cosine 2x with respect to x is minus sine 2x over 2. And then we'll subtract 1/8 times, and we'll rewrite this like so, 1/8 times the integral of cosine 6x with respect to x is sine 6x over 6 plus the integral of cosine 2x is simply sine 2x over 2. And because these are indefinite integrals, we'll add a constant at the end. Finally now, all that's left to do is to distribute these coefficients and simplify. So we'll start off by doing the 1/4. We've got x over 4 plus sine 4x over 16 minus sine 2x over 8, and then we've got a negative 1/8 here, so we'll do minus sine 6x over 48 and then we'll do another minus because we're distributing that over, sine 2x over 16 plus a constant. And now we need to gather like terms. What we've got is we've got x, sine 4x, sine 2x, another sine 2x, and a sine 6x. So we'll rewrite x over 4 first, and then we'll move on to our 2x's here. So what we've got is we've got 1 sine 2x over 8, and then another one over 16. We'll multiply this one by 2, so we'll have 2 sine 2x over 16 minus, and this is already a negative, minus an additional sine 2x over 16. So we get minus 3 sine 2x over 16. And now we can grab the sine 4x. We can add sine 4x over 16. Go ahead and subtract the sine 6x over 48. And then we can get rid of all this. And we can add our constant at the end. And this is the final solution to our indefinite integral. If you have any questions, leave them in the comments below. Otherwise, I hope that you found this helpful.